Everyone, a very warm welcome to day 2 of this insightful and engaging conference. To begin today's proceeding, we are honored to welcome a distinguished personality from the Indian oil and polymer industry, Mr. Vikram Soni, a qualified professional with MTech in Polymer Science and Technology from IIT Delhi, having extensive experience in the flexible packaging industry, demonstrated expertise in product development, technical support, and application development, particularly in the area of polypropylene and polyethylene. He also played a key role in the successful establishment and market penetration of IOCL's PP and PE grades produced from Panipat as well as Pradeep plant in various sectors across various regions, Maharashtra, South Gujarat, Daman or Silvassa, MP and CGS. Presently working as the Chief Manager at Product Application Development Center, Panipat. Today, he will be delivering a keynote address on development in technology and its application in polymers. Please join me in warmly welcoming Mr. Vikram Soni with a round of applause.
Good morning. I think a lot of talk has been done yesterday about how the polymer importance in day-to-day life. A lot of question has been raised about the sustainability and how the sustainability questions being raised and how the companies like Brazil manufacturers are taking steps towards the sustainability. So I will cover in my topic the different manufacturing technology which is used for the polymer, polyethylene and polypropylene. Yesterday already, Pastor has discussed that all the technology which we are using to manufacture the polymers is no domestic manufacturer have the license. We have to take the license from different companies like Basels. So we have to take the license from different companies like Basels. We have to take from Exxon, Dow, Grace for different. All the technologies have a lot of positives, but not a single technology is suitable for all the applications. So I will just start with the polyolefin technology development, which started in 1890. We say the first the trace of polyethylene was, but it was not considered as a polyethylene. Was the vaccine material in 1930, first LDP discovery. After that, a lot of research work has been done in development of the catalyst. (1950 to 70) development of Ziegler and the Phillips catalyst. So, start of linear low density polyethylene and unimodal and the bimodal grade productions was possible. There was technology to the Australia from the Basel market from Sherman Phillips and Uniform introduced. In the 1980s, early generation catalyst innovations. So 90s focus on the higher throughput. When you go for the commercialization, so there's the yield of catalyst performance, how the throughput can be increased. That was much more concern. After 2000, there was a wave of lot of technology, lot of plant has come. So in fact, in domestic India after 2000, a lot of capacity has come in polyethylene and polypropylene. So current, if you right now the need of the moment, the high performance products, because most of the technologies are very common right now in the domestic markets. Most of the grade which is produced available are the commodity grades. So the current need is how we can differentiate with the grade which can be produced, which can give the additional value added performance to the products and which can differentiate with the commodity polymers. In polyethylene, the evolution to revolution through catalysts. First, the polyethylene was developed by ICS 1930 high pressure process. Was the accident discovery with the ethylene, and it was tested the high pressure, how the ethylene will react and what come out. And that time with accidentally this polyethylene was discovered. After that, the development of the catalyst, we were able to get linear polyethylene, LNDP, and the process was also low pressure process. And after the Ziegler data, the Matlusin catalyst developments. So that developments has taken a lot of development in and given the broader scales in the polymer LLDP to use in the flexible packaging industries. So after Matlusin single site catalyst developments, so there was a lot of market has been and a lot of new plants has come, and it creates a lot of value in the polymer flexible packaging industry. That's why the reason the rigid packaging has been replaced by the flexible packaging with the lighter weight up to 50%. In polypropylene, after the Ziegler data, after the NATA has synthesized polypropylene 1954, there was a need. That time, the yield of, if you see the yield of the catalyst from 1.5 to currently is the 40 to 60 kgpp per gram of catalyst. So initially the development, the yield was very low. So then the development started with the MgCl2 supported catalyst and high yield and high stereoregulatory polymers developed to that development of the catalyst, and electron donors, internal and external donor developments was there. So through that you can get the high yield mileage, very high yield mileage, and also the desired stereoregulatory was achieved. Some of the morphological control catalysts, reactive catalyst technology, RGT. So the critical factor for the catalyst, nowadays the yield is very important. Catalyst higher activity and productivity levels. So how can we increase the yield and same times whether we can differentiate with the polymer properties with the conventional catalyst available in the market. Catalyst stability is also sensitivity to the poisons, reactor operability and control, how reactor throughput will affect it, and reactor continuity, startup and conditions, control of the polymer properties, molecular weight distributions, and co-polymerization kinetics. So these are some critical factors for the successful catalyst performance. Manufacturing technology, initially high pressure and low pressure process was developed for linear low density polyethylene, and LLDP. So discovery 1933, first discovery was polyethylene by Frankfurt and Gibson. It was the pressure of 1400 bar, and then 1939 the first commercial plant has come autoclave by ICI, and 1941 ICI licensed the technology to bond 41 union carbide with first tubular pilot plant. Difference autoclave and tubular is autoclave gives more broader molecular weight distribution than tubular, and for the applications like extrusion coating, where the netting is the more major concern, where the thickness of the coating is around 6 to 8 GSM in different applications, where this autoclave grade, which is produced through the autoclave LDP grades, has better performance than your tubular grades. The first commercial tubular plant by Union Carbide, DuPont built up first autoclave plant in US under license from ICI. So autoclave, because of high pressure, 100 to 2000 atmosphere, initiators were the peroxide, multi-joule reactors, multiple initiator injector points. So basically advantage was with this you can get the higher branchings, which was very important to get the band strength of the polymer. The conversion was 28 to 30%. 80 kTA plant was initially, earlier it was known as the IPSL, currently with the Reliance, in Vadodara is this autoclave and reactor. And then tubulars also, operating pressure much more higher, 4,500 to 3,000 bar. Conversion is slightly better than autoclave, 30 to 38%. Reaction showed 4 to 6. So multiple internal diameters, raw density rate we can achieve 915 to 935. So Reliance currently, earlier it was the IPSL plant, now the Reliance. For low process we can differentiate the different process like slurry, gas phase and solution process. And slurry also, the heavy diluent, light diluent or gas phase, pretty fluidized bag reactor and strip bag. And we can further slurry can be loop or CSTR based on the reactor, it's a vertical reactor system or the horizontal reactor system. Basically through the catalyst and the reactors, different reactor system, you can decide the molecular weight distributions. You can use different reactor in the series, you can use in different reactors in the parallel to get the different molecular weight in different reactors, and then you can have the broader molecular weight distribution by model or the multi-model weight can be produced. Some of the technology variations in terms of which comes in polyethylene technologies. It's a gas phase process, unipol, inovane and spiralene. You can get the unimodal SDP, bimodal also, LLDP, and the catalyst, Jiggler data and chromium and single site catalyst. So, like that, in inovane case, you cannot get the bimodal products, but unipol, you can get both unimodal and bimodal. And the gas phase products by spiralene, you can get all the range of density. You can produce LLDP, you can produce medium density polyethylene, that is very important in the gas pipe applications, city gas distributions. That medium density polyethylene pipe grades are used for such applications. In slurry process, Bartek single loop reactor systems, unimodal, that's why. And after developments, it comes additional dual loop reactor system where you can get both unimodal and the bimodal, SDP as well as LLDP. And Mitsui was also slurry straight tank. Solution process based on the CSTR cascade and the loop cascade based Dow and Dowlex 2 technology installed. Solution medium premium pressure cascade, Sclatec, and nowadays it's advanced Sclatec technology is available where you can produce this ATOC through single site catalyst. Then high pressure free radical process. So these are the different technology variations. These variations comes with the use of different reactors and the different catalyst system which you can use to get the different molecular weight distributions products for different applications. First generations, so slurry process, simple in operations, high conversions, purity of the products is good, medium to high molecular weight products can be produced. Heat removal process is easy. In solution process is one of the process where you can produce very good LLDP film grades. But the drawback with this process that you are using a solvents like cyclohexanes. So you need to add different separation process in the different step to remove of this cyclohexane. In fact, in this process, still the extruder where you are going for the pelletization of the product, this 2% cyclohexane is still available. So that for the application where you need organoleptic properties, there is a concern about the order, just like this mystery bottle which is aqueous. The caps of this bottle is made with the CCM process, continuous compression molding process. The screw active machines where this sensory order test is very important. If you are producing the grade from the solution process, and if you are producing the same grade from the gas phase process, gives the better performance in terms of organoleptic properties, in terms of order performance, which is very, very critical in such applications. And obviously, the solution process, you cannot get the high molecular weights. This is the limitation. But the grade which you produce, alum film grade for the flexible packaging applications, there will be the very less gel in this process. So this is the benefit for the alum film applications for the flexible packaging. Solution process is a very good process. IOCL, we have CSATPP 300 kVA plant at Polymer where we are producing LIDP and SDP grades. Different processing conditions, temperatures, slurry versus loop reactor versus the CSTRs, temperatures 80 to 105, 70 to 90 degrees centigrade. Pressure is a similar kind of slightly higher pressure in the loop reactors. Residence time, which is very important, 1.5 in the loop slurry part of loop reactor, and in the CSTRs 2 to 4 hours. The convergence, similar convergence. In case of CSTR, hexane is used as thermal and isobutane. The comonomer hexane or butane can be used. The catalyst difference. So Chevron Phillips, the technology which is based on the loop reactor, and the Hessian vessels is based on the CSTR. Solution process, low pressure and medium pressure, 180 to 270 degrees centigrade as the temperature in the medium pressure, and low pressure 130 to 180. Residence times in low pressure 5 to 20 minutes, medium pressure 22 minutes. Per pass percentage conversion same 95. Cyclohexane is used mostly as a solvent for this process. The density range is similar, but the only drawback is in terms of the cyclohexane solvent we are using and the high molecular weight we cannot get in the solution process. The second generation comes gas phase process, safe to operate with the few control parameters, catalyst, gas compositions, temperature. Highly energy efficient process. So a lot of technologies which comes in the plant levels, lot of concern was made how can narrow down the different process for making the products, how can we minimize the hardware setup in the reactor system or the total organization system. That is very concerned. So through the gas phase process, that is the best advantage. If you compare the cyclohexane, the SCLATEC technology, which is older technology, you have to use adsorbent bags to for the catalyst removal, and this is the very the process where after 2 to 3 days, if you are not getting the color index, desired color index, you have to change the entire bag. So that is the very concern. It's a time-taking process. In the gas phase process, you don't need such kind of a setup for that. Easy to enter the molecular weight and molecular weight distributions. The process parameters, the catalyst supported titanium, vanadium, and chromium. Catalyst size, pressures are slightly higher in the Unipol. Unipol, the grade which is produced through the Unipol process, very good performance in, as compared to the inner grade. The control in the molecular weight distributions, changeover penalties is much lesser in comparison to inner grade. Third generation process. In third generation, we can produce multimodal grades, multimodal molecular weight distributions. In case of HDP, when you're going for the high molecular weight distributions, you are producing in one reactor the grade which is having the MFI up to 100. In fact, if you want to produce the grade for the multimodal with this cap application, in the first reactor you have to make the MFI up to 200. Just like a vaccine material. So how the hardware comes in that code, you have to set up the wax separation units also. You cannot design the plant based on that. You cannot produce the high model, multimodal polymer in your technology. In the Hosling process, reactor systems are there, 3 reactors, CSTR reactors are there, but we cannot produce this multi-model grades. But the advanced ACP technologies, there is the option where you can control different molecular weight in different reactors, and where you can produce multi-model grades SDP for such applications. So these are some of the technology which is currently available in the domestic market. We call LLDP SDP swing. We call it the swing because we can produce both LLDP grades as well as the SDP grades in that technology, in the same technology. The grade which is produced LLDP is mostly at the film applications, flexible packaging, rotomolding grades, so as for the overhead water tanks, the hollow products which you are making, and for the XLP compound for the wire and cable applications, and the high flow material for the master batch applications, and SDP, mostly SDP injection molding grades, SD raffia grades. So these are the grades produced in the swing plants. So this is Clartech. Reliance as well as GAIL and IOCL has the same technology. Autoclave reactors, generally the one reactor is only used, the pipe reactor is there. Pipe reactor rarely used in one or two combination where we are required stress component like narrow molecular weight distribution requires for applications like monofilament applications, all the SD raffia tapes for the fertilizer bags, or then this combination is used. Unipol is better in terms of Clartech because in univation you can produce the mass with a single site catalyst, you can produce the macrocene grade also. In India, GAIL earlier has taken the to start the productions of macrocene, but recently last year HML has added 2 swing lines for univation 400 kTA each, 800 kTA, where they can produce the macrocene grades. And the good thing is that the performance of the grades, which in terms of if we compare with the Exxon, the Dow grades, macrocene grades, they are getting equal dart impact per microns. Generally, normal Ziegler-Natta based catalyst, if you are producing the LLDP film grade based on the beauty as a tone monomer, you are getting the dart impact hardly 3.5 to 4 gram per micron. If you are using the octane, the same Ziegler-Natta catalyst, you can get hardly 6 to 7. But if you are using the macrocene grade, you can get up to 25 gram per micron. So this is the difference in terms of performance of the properties of the grade which is produced from the Ziegler-Natta base and the macrocene catalyst. So all the flexible packaging, all the inner layer which is the seal with the products, which is attached to the products, the sealing layer is that most of the cases, 80% this is macrocene based LLDP. And spirulina, Haldia has the spirulina technology. The drawback with this technology, the color index very poor in terms of as compared to innovations and Nova. INEOS also the Opal has started in 2018, 720 kT capacity. The catalyst Ziegler, chromium and single site catalyst can be used, but in their license Opal doesn't have that license. And the Boruch, which has these technologies where the loop reactor and the combination with the fluidized fat reactors, butene, hexane and the single site catalyst can be used for the such applications. So different technology with different grades, range of from MFI to density for the different applications. So univations, unimodal and unimodal grades for the LL frame applications. Nova Cam or univation, you can get the range of the MFI, the density which you can get with these products. And the spirulina comes to just in between 92 to 94, and INEOS and the Borealis comes to the right of the side for applications like SD injection molding, SDR, and SD glow and biomotor grades. So these are the technologies preferred for such applications. So not every technology can produce the grade which can suit to your all the applications. Different technology have have different positives for different applications. Sclatec, this was the older Sclatec technology, but advanced Sclatec comes with a single site catalyst, 2 CSTR, and a single reactor can be operated, both reactor can be operated in series, butene and octane, and in that advanced Sclatec technology, you can produce the use single site catalyst to produce matrosine grade. Very narrow molecule difference between Giglia-Nata and matrosine single site catalyst gives you much more narrow molecular weight distributions, so more viscous materials. So there is also the penalty in terms of the operations at the plant level. The domestic available capacity, the problem is that we don't have more number of lines. I have Sclatec 1 lines, Junivation, HML has started taking the 482 lines, 880. Don't have separate lines where we can run the dedicated matrosine grades. Because when we go for the change over the grade, you have to pay 4 days penalty for the productions. So that kind of viscous materials produced through the matrosine. Player like Exxon, player like Dow, player like Boros, they have the dedicated line where they can run only the matrosine grades. So in any line, obviously, if you are running the single grade for the longer run, you will get a much more consistent product as compared to if you are running for just the 4 days or the 5 days and taking the shutdown penalty for 4 to 5 days. So the penalty of 4 to 5 days is a huge quantity in terms of financial losses. That's why no domestic manufacturer wants to come with the bigger lines in the matrosine. But if we can take the smaller lines like 150 or 200 KTA, where we can take regular runs for the 10 days and the 15 days. So this is the challenge to run the matrosine based grades to produce the same lines.
Sclatec process uses a combination of pipe, reactor, and automated.
That's Junivation. So this is Univation's. This is a technology where you can produce wide range of the grade and different catalysts is available to produce same technology SDP grade for the pipe application, HMSDP, high molecular weight, high density grades for the applications like pipes, and the same time you can produce the film grades. So different catalysts, you can produce injection molding, film, SD blow, large blow molding products, pipe grades, pressure pipe, PADP 100. You can produce the matrosine. So HML has taken, last year they started the productions where they have the similar technology and they can produce the matrosine grade technology. These are different catalysts. Through this catalyst and the reactor system we can use in the series, in the parallel, we can produce such kind of products in the single technology. But it depends on how you take, when you take the license, so how you take the license for these all the products. So that's why when you're going for the licensor, going for the new technology, licensors not giving you the full package because this is the cost. And the new technology always, they will prefer to hold at their end unless and until they get the new one, the better one technology. So this is the difference that in domestic market, most of the technologies are producing similar kind of grades. And that's why the imports come still, polyethylene is like more than 1,000 PPA and polypropylene is also approximately 50 PPA. Such application like matrosine or some kind of elastomers or blastomers still are totally dependent on the imports. And obviously the cost of the operations, cost of operation 35% lower than the other process. So this is the advantage of matrosine. If you compare with the Ziegler-Natta catalyst, the heat sink temperature, heat sink initiations is much lower than as compared to the normal conventional LLDP grades. And the dart impact performance as compared to the normal from 3.5 gram per micron to you are getting 25 gram per micron. So this kind of difference which creates much more difference, and this is the reason why with the matrosine down gauging was possible up to 50% as compared to the earlier which we have produced in the fields. dedicated SDP. Basically, dedicated SDP is called we are producing the SDP grade and HMSDP, high molecular weight, high density. There is a sector called blow molding, general purpose blow molding, so all edible oil container, normal container, pharma, waters, that is called general purpose. And then the MPMs is up to 200 liter containers, and the large blow molding containers where alvin containers called blue containers, that is called alvin containers. These can be produced through the dedicated SDP. This is the slurry process where you can get much more high molecular weight as compared with solution process. So there are the Mitsui chemicals. Mitsui performs, this technology gives much more superior products as compared to some of the technology, because in SDP blow molding grades, which is produced through this Mitsui, and the pipe grades having the much better performance. In fact, the Haldia petrochemical, which having this Mitsui technology for this, they are producing P100 grade. P100 basically the pressure rating. It's called MRS, minimum required strength, and that has to be certified through the regression analysis for the long-term hydrostatic test is required, and for the 10,000 hours, and gives you the performance guarantee certifications for the 50 years life, for 50 years of service life at 20 degrees centigrade. So they are able to produce the MRS value up to 12.5, and in their blow molding grades, they are also using propylene as a co-monomer, also in case of polyethylene grades. The Hostling, IOCL, we have the Hostling technology. Hostling grades are better for the pipe grade applications. All the pressure pipes, PAT, as being P100, which is used for the water distribution. All the black color pipes which you are seeing for the water distribution, different pressure rating systems are there. It is used. And the Reliance is also the Gandhar small capacity. Basically, in these reactors are the series, and Z501 is the ready-made catalyst which is used. Butene as a co-monomer. This Chevron Phillips, this is the first technology after long time. So the first technology which has come to India is Chevron Phillips. Chevron doesn't prefer to give this technology. You can produce large blow molded grades. PR57 globally is the well accepted grade for such applications. Reason behind this, you have to produce very high molecular weight and very high viscous material. Viscosity in terms of 21 kg load, the MFI of the material is maintained from 2.5 to 3. It's very difficult to produce such kind of grade with the Hostling or any other technology. Again, when you are producing such kind of grade, unless and until you have the dedicated line, you will not be able to produce such a consistent grade in such a narrow range of weight. So that's why this Chevron Phillips technology is much superior than any other technology. And hexene also is used as a combo. The challenge is that the hexene is not available in India, so you have to be dependent on the imports. So all the pipe grades like P125 grades, which is required for not only the 50 years, more than 100 years of service life, is produced through this technology. This is the Hostling ACP, advanced cascade process, as compared to the Hostling conventional. In this, you can produce very much higher molecular weight products, multi-modal products for applications where you require. But the challenge is that you can produce in the same reactor the high molecular weight, but it will not be suitable for the processing. You can produce the high molecular weight whatever you want in the one reactor, the two reactor system, but you will not be able to process at the machine level. So that is why this technology has play the important roles for multimodal kind of molecular weight distributions, which create the processability windows also and create the high molecular weight in terms of the performance. So the 450 kg plant, which is started last year, the Phillips chromium catalyst and Giglanata catalyst. Macrosig is not the part of licensor. Case of HML for these grades. Judy model, bi-model capacity, slurry process, hexane is the co-monomer. As a grade transition time is 3 to 6 hours. So limitation on the number of grades to be produced. So widely licensed 21% capacity in global is in this technology. In fact, the pharma bottle which is produced, all the 50 cc or 100 cc or 150 cc bottle, all the pharma application, that is also produced from the second CBF line. This is the only grade which is produced from the Chevron Phillips technology is accepted globally. The domestic market also for the US FDA, Canada FDA, which is produced here, is all based on the grade is used from these technologies. So with this technology, you can produce blow molding grades which is created in the pipe extrusions. Film you can produce, but because of narrow molecular weight distribution, you are able to produce high molecular weight products. The performance in terms of processability and bubble stability is a challenge for the grades which is produced from these technologies. This multi-model is just explains the Borstar, Boruch has very high in the technology, and that's why their grade basket much superior than any licensor. And their technology is not much available data about how they are producing. You can get the reactor system, but still there is much lesser information available for such kind of technologies. Where you can use loop reactor system, single or two loop reactor or three loop reactor with the fluidized bed reactors. The only and in case of Unipol or the Spirally, two gas phase reactor can be used. In the Hostling ICP, three different kind of reactors. In each reactor, different reactions, and all the output of the one reactor is will be the input of our other reactors. So the different molecular weight distribution, molecular weight fractions rate can be produced. Some of the this multi-models advanced new age P technology which is called Hyperjon. This is Hyperjon's 3x2 cascade reactor setup. Basically, it's called multi-zone circulated reactors, and the catalyst system where you can produce very much superior high molecular weight. This technology can easily give the consistency in terms of molecular weight distribution, and different set of molecular weight distribution, narrow, broad, and much broader. So in the curve you can see the different molecular weight distribution products which is to produce through this reactor system. And the same Borstar third generation technology is based on similar kind of not the Hyperjon system, but different loop reactor system combinations where you can produce this. With this Borstar, the supercritical propane done as used as diamond, and can produce homogeneous tri-model molecular weight distribution products. So this is tri-model something. So for the P125 or the large blow molding grades, these kind of technologies is very suited. So how the change has come in the products quality and product requirements. The normal SDP grades which we are producing earlier, in 1970s developments earlier, the P32 or P40 classifications in 90s, the different P50, P63 classifications. Presently P80, P100 and P63, P100 plus. But new generation you can go about more than 100 P100 classifications, P125. What is the limitation when you are going for the large diameter pipe? In fact, from 1000 to 2000 or 2500 pipe. With the normal technologies grade, which is P100, although it is certified for the P100, and you're producing the grades, there will be sagging because the size of the diameter of the pipe is such kind, unless and until there is a much high molecular weight fraction is there. And for high molecular weight fraction, for such high level, you need the combination of the low molecular fraction to take care of the processability. But conventional hostline of the grade which is produced right now cannot handle such things. So there is the problem of the sagging during the productions. these can be handled through the technology like chevron flips or this multimodal gate which is produced, where you can produce such kind of flies. Actually, for the longer life, the 50 years certificate, this kind of certification is taken from the testing agencies called Element. Earlier it was known as the body code. This is in Sweden, so where it takes 1.5 years time to test and give the certification. Unless and until you get the certification for that, you cannot supply your gate for the project-based applications. So mostly the demand which comes in the water distribution or the city gas distribution, the gas pipes comes from the such kind of products. And that has to be must to certified from the international agency, and overall there is one agency is Element for this. And there is also condition, they should not be, when we going for the regression analysis for long-term hydrostatic test, there should not be any brittly before 5,000 hours. So that is the challenge with the conventional technology to produce the grade where you don't get any brittly. For the gas-based gas distribution application, that is must, that there should not be any brittly. Water distribution application, you can use such kind of grade. For the gas distribution applications, these grade cannot be used. This is the capability of various process summary, different gas phase or solution phase. So how much range of density and the MFI you can get the different processes. Solution process, you can get the higher range of MFI. The gas phase, lower MFI range and then the density. So every technology has some range of material which is going to be used. Gas phase is definitely the process has the widest operating range, but some difficulties all there. Very low density due to stiffness and particles agglomeration issues are there. So these were the some of the technology which is currently used for the manufacturers of polyethylene. For the polypropylene, similar first generation, second generation, third generation based on slurry process, accessory, liquid bulk, and liquid bulk without extrusion in the gas phase process. With the reactor system. So all the technology is differentiating based on the catalyst and based on the reactor system. You can either you are using the fluidized bed reactor or you are using CSTR or using the loop reactor. Actually this is economical as well as the space constraint which is required to use. It looks like very simple in the designing currently which I am showing to you. Just preheater of any which is used in any technology, the size of the preheater is just like the macro pillar. Assortment bags is similar kind. After 3 days or 4 days operation, every time you have to clear the absorber bag, and you are handling the hydrocarbons. So safety is much more concerned. There is no say to sorry for any mistake. Any slight mistakes, there is no possibility of chances. There will be mostly the casualty, and such kind of operation when you handling producing this polymer, the safety is much concerned. This is the reason why no LDT plant has come. Earlier only the IPCL has these plants. No other capacity has come till now in India, despite of their requirement. LDP is much required, having much superior non-distance as compared to LIDP. Any blown film application which is producing the film without the 15% or 20% of addition of LDP, you cannot process. So this is also must required. So patient polypropylene is also based on the reactor system, Rostars, loop reactor, and the fluidized bed reactor. If you are going for the impact copolymer. In polypropylene, you are making homopolymer, random copolymer, impact copolymer. For making the impact copolymer, you need gas phase reactor. You can use single gas phase reactor, the two gas phase reactor. Obviously, double gas phase reactor gives much more flexibility in terms of EPR distributions. Because in gas phase reactor, you are making ethylene propylene rubber, and the distribution of that rubber in the polypropylene matrix is very, very critical in terms of performance. The Spherical, we have the Spherical technology where the two reactor systems, and we have single gas phase reactor system. Exxon has the two loops, two fluidized battery reactors. Innovin has the one APIA and horizontal step gas phase reactor. Normally the gas phase process, single gas phase reactor plus one more absorption, Junipol also. So with the these reactor systems as well as the catalyst and the donor system, you can produce various grades for different applications. In case of polypropylene, obviously donors plays a very critical role because the donor earlier the donor was benzoate or phthalate or succinate. Based on the different electron donor system as donor, we were able to get the higher throughput, higher yield through these polymers. Phthalate earlier it is used because we are getting much better yield like 40 to 60 in terms of isotactic index from 97 to 99. But now again the challenge has been done to the phthalate because this is the carcinogenic. Regulatory norms has come. So now the new technology which has come, new plant which has come 2 months back, Niara has started with polypropylene 9. The HML, the second polypropylene 9, the Spherical 2 which is started last year. Both from the first day of production, they are claiming the phthalate-free catalyst they are using. So the importance now, the much more concern in terms of regulatory norms. So the electron donors has been changed from the phthalate to non-phthalate. Although the phthalate, obviously you are using the phthalate electron donor in the catalyst system, the final product will be meeting the regulatory requirement. But now the stringent requirement has come, the phthalate should not be anywhere in the part of your polymerization system. So now more concern has come, such kind of system where any carcinogenic or any harmful substance cannot be used in your polymerization system. So the change has come from the phthalate to other. Mostly phthalate or the diether give different molecular weight distributions. For different applications, diether gives you much more narrow molecular weight distributions. The product like fiber and filament, like hygiene applications, non-hormone applications, the diether based performance is much better than the phthalate based performance. So these are the domestic capacity currently more than I think. Approx 6600 kg is the capacity currently for the polyethylene and polypropylene, and polyethylene is approx 6100 kg and approximately 2500 kg this product is required. So the overall consumption or demand you can get the idea. So these are the Reliance has the advantage that they have the number of lines are much more and at a single place. So they have much flexibility in terms of grade changeover. Every time you change the grade, there is a penalty of the grade changeover. As you change the catalyst, because say single catalyst system cannot be suitable for all applications. For BOPP application, by actually oriented polypropylene using different kind of catalyst system. For a random polymer or the impact polymer, you are using the different catalyst system. So, number of catalysts, number of the grade changeover. You have the multiple lines, you have the much more flexibility in terms of the grade change. So Niara has started just 2 months back this Unipol. They have Unipol technology 450 kg. We have 2 lines in Panipat. One line is Spherical technology from the Basel. One line is dedicated for the impact polymer. We have one gas phase reactor. In Paradip also we have 2 lines 340 kg which is Spherical too, but we are producing only homopolymer grade. A very common process, simpler operations, high conversion, high purity products, capable of producing high molecular weight resin, long residence time, recycling of the damages that are also that mismarket advantage. So how the, just see the first generation's process for the first number of steps which is required, each number of steps, for polymerization to get start of from the reactor to get the granules. So lot of work has been done on how we can minimize this process. So in the first generation process, the capital cost, obviously operating cost will be much higher because of that. Large number of equipments, large inventory of solvent has to more energy is required. Attacking polymer removal was also a challenge, and catalyst reactions was also the constraints. The second generation from 8 to 7, no catalyst reaction is required. If you compare the process parameter, slurry loop you can be able to run at much lower temperatures. Conversion and CSTR case, the conversion is much better, 97%. Second generations, again the further plant size has been from the 8 to 7 to the 4. This is called spherical. And spherical, because of operating cost, because of new reactor systems, we are using simple to operate, energy efficient, and removal of APP is not required in this process. So in this spherical process, specialty grade for 8 cylinders BOPP. The BOPP, all the confectionery products, the chips, the inner layer is BOPP, heat soluble BOPP is used, and this heat soluble thickness is only the 1 micron or 2 microns. And most of the grade, all the grades is imported right now. No domestic manufacturers producing such kind of grades. Random copolymer grades you can produce. ICP impact copolymer grades is better you can produce. High microstrength polypropylene. So this is the broad range of different products for the MFI from 0.3 to 1600 gram per 10 minutes. 1600 gram per 10 minutes MFI material used in diaper applications. Is the we produce non-woven products which is called spun bond process, but for the hygiene applications, their multi-beam process has to be used, spun as well as the man flow. The man flow, the MFI of the products are 1600 to 2000 MFI. So just think about how the control can be done for such high flow material in the reactor system. Xylene solubility high, 90 to 99%, but it is not required. You need some atactic contents also in the polymer. For applications like biaxially oriented polypropylene, you need such some portion of atactic portions also. In the raffia tape manufacturing plant for the woven sex applications, for the cement packaging, which is you need such, because stretching is taking place. Biaxially oriented polypropylene, we are stretching the film 10 times, approximately 10 times. Machine direction as well as transfer directions. So that's why the atactic portion is required for such application. Sealination temperature for random copolymer up to 115 degrees centigrade, flexible modulus 500 to 2200 megapascal, iodide up to 750. The challenges comes in all for the domestic manufacturer who produces the ICP, the ethylene propylene rubber distributions. We generally follow the easiest routes, increasing the C2 content much higher and to get the higher isoleic package strength. For compounding application, all the auto compounding application, they prefer higher MFI material because they need so much dispersion material is required, glass fiber, talc, mica, a different kind of polymers is mixed in a single recipe. For the bumper compound which is used for the bumper application, different recipes is used. And when we going to produce no break grade, which is called greater than 500 Joule per meters, the isoleic package strength, where we get the distribution is much more challenge. So the rule is that anything has to be compatible with the, then it has to be the similar nature. Because in first reactor, in ICP grade production, you are producing polypropylene. In the second reactor, you are making EPR. This EPR has to be distributed to polypropylene matrix. If your EPR level is having C3 rich, so its compatibility is distributions will be much more superior. At the same time, you can get higher iso impact strength without losing the flex drum modulus. So your auto component application, stress biting is for the luggage shell application, stress biting is much more challenges right now. For the, as you increase the impact strength, you increase the EPR content, and for such application when there is drop and impact in the product, then stress biting generates, which is not desirable. So that's why if you have the multi-gas phase reactors, two gas phase reactor system, this gives much superior performance compared to the impact polymer which you are producing through the single gas phase. So that's why this role of reactor system comes in terms of performance of the grades. Some of the applications, I'm just showing the grade which we are producing, the impact polymer grade from 3.5 MFI to we are producing 65 MFI grades for auto component applications. For the appliance, the 40 MFI grade impact polymers are used, and injection molding from homopolymers, this 1110 MAS. These are the nucleating grades, and ICP 40 MFI, 12 MFI, 65 MFI grades. And the medical and pharma applications 1200 MC, which is yesterday discussed for hygiene application, disposable syringes, and the 1350 YG and YH. YH is the grade which we produce that we claim as the halide free because there is no halide in the system. Some flexible packagings, utility grades, and the raffia rigid packaging. So these are the different applications, the number of it. Currently we are producing more than 60 number of grades for such kind of applications. Third generations, the gas phase, plant size further reduced, the capital cost less than 10 to 15%, very simple to operate. Again, the ABB renewal is not required. So these are some technology, Unipol and Noblin and INEOS. So Unipol, more than 100 licenses. Unipol grade will benefit some of the grade like PADC or polypropylene grade, very well accepted, which is produced with this technology. Noblin has some limitations, vertical helical agitator reactor. In terms of molecular weight distribution, in terms of xylene solubility performance, lacticity, Noblin still has lagging in terms of performance. INEOS, the reactor system, is horizontal spec reactor system. From the vertical to horizontal. Faster product transactions, higher productivity, and narrow molecular weight distribution can be. Which is just like as a plug flow reactor. If you are using this reactor in the horizontal. Adipol has a limitation that the product which is produced doesn't have required extrusion because it becomes like a spherical piece. It's not the granularity is the problem. For the applications like extrusion application, the grade which is produced from these applications is not acceptable. Relax as the one line with this Adipol. New age technologies, Sperizone. This Basel have the most advanced polypropylene technology. Product portfolio. It is similar to the multi-zone circulating reactor systems, where one MJCR plus optional full-size battery reactors. The catalysts with different gas composition. Biomodality can be achieved, and the grade which is produced, the polymer grade. Any technology which is currently available, not all technology can produce the polymer grades. That polymer grades can be produced from these technologies. And the basal catalytic PP process. 3 independent flash bag reactors systems here. So all the thermoplastic olefins, the grades like ATFLAX and ATC, these are the color polymers. So these grades are produced from these technologies and can be because of the reactor system, the catalyst system which is used, the color polymer can be, although it is used in the film applications hardly 1 micron or 2 micron, but is the functional layer. And despite of spiripol, we can produce ductile polymer, but it's not accepted in the market. That's the challenge. Only the grade which is produced from these technologies, ductile polymer, is accepted. MFI from 2016, xylene silver 1999, fluxing modulus, arginine registrant. Highly homogeneous multi-molar monomer resins, unimodal or bimodal from single reactor. Polymers with having extremely high purity. Morphology control of particle size. Require another gas-phase reactor to produce effective polymer. Post-stop process is similar to spiripol, reactor and then gas-phase reactor in the series. These are the various technology which is currently available for the polypropylene. If I summarize different technology, polyethylene multi-model is the one which is creating the differentiate in terms of the grade performance, and technology which can use the Matlusin catalyst, creating the differentiation. In the PP, lot of differentiate is done through the catalyst and the electron donor systems. So increasing the activity of the product, how we can increase the yield of the product, stereoregulatory, the catalyst is the polymer is very important in different applications. So that's why the catalyst, when you're going for the licensor, the catalyst you have to take from the licenses only. And if you are using any other catalyst, the challenge in the domestic market, we have currently 4 number of lines, and 2 more lines is coming in probably next year. One is in Vadodara and one is in Baroni. So it is important to us to develop that catalyst source from the domestic market because it requires more than 400 crores of expenditure in catalyst system. And Ziegler-Natta is already the domestic manufacturer producing, having capability of that. But now as the number of lines is increasing, the company like IOCL, the company like Land, they are exploring the possibilities whether we can use this kind of catalyst from the domestic resources. We are also looking for, we already have taken some of the trial, but the only challenge is anything goes wrong in the plant, you will not get the support from the licensor. So you have to be well efficient with your particular data and your team that any challenge has come and you can take up this. So these are some of the challenges in terms of developing technology and licensor limitation which we have.